Kyoto Fusioneering is celebrating our 5th anniversary this year. Founded in 2019 as a Kyoto University spin-off, we have grown to 130 employees with operations in 5 countries. Our core business is fusion system integration. We are developing 3 core technologies that are critical components and systems for the fusion pilot plants and power plants we are designing. First, the gyrotron systems use the plasma for fusion reactions to occur. Then the energy generated from the fusion reaction is extracted and used to produce electricity via the fusion thermal cycle. Next, the fusion fuel cycle is critical in ensuring that the fuel can be processed and then circulated for a stable and constant fuel supply. We aim to be a key partner for companies and research institutes around the world. Currently, we are building gyrotron systems for delivery to the UKEA and Tokamak Energy in the UK, General Atomics in the United States, and other clients. In parallel, we are constructing integrated testing facilities called Unity 1 and Unity 2. The Unity 1 facility is based in Kyoto, and the Unity 2 facility is being built in Ontario, Canada, in partnership with Canadian Nuclear Laboratories and Fusion Fuel Cycle Inc. These key facilities will integrate the critical components and systems needed for fusion power plants. Those are essential for the development of fusion pilot plants and agnostic to almost all types of reactors. Let's take a look at those core technologies in more detail.
One of our major activities is the gyrotron. The gyrotron is a 1 megawatt level microwave source that is used for the plasma heating to occur the fusion reaction. This heating method has a great advantage that the system is simple and maintenance is easy. This gyrotron development has been performed by the effort of many researchers and industries for many decades, and 1 megawatt level stable power generation was realized. Kyoto Fusioneering is now providing the gyrotron in worldwide. The great merit of a gyrotron is that the frequency can be selected by changing the operation parameters. Recently, we demonstrated the 5th frequency, 236 GHz, using the multi-frequency gyrotron. This gives a great flexibility and possibility for the fusion plasma research and reactor design. Kyoto Fusioneering will contribute to the fusion progress from now on.
Unity 1 is the fusion thermal cycle technology demonstration loop that is currently being built in our Kyoto Research Center in Kyoto. That Unity 1 loop recirculates lead lithium, that is liquid metal, to transfer the fusion heat, in this case the simulated heating by the induction heating, to recirculate the fusion energy to be transferred from the blanket that will receive the fusion energy to the thermal cycle that would convert the heat to the secondary driver of the turbine and the electricity generation to be demonstrated. That will be installed in Kumiyama next year around the summer of 2025. That is one of the first attempts in the world to simulate the fusion electricity generation. The Unity 2 is a fusion fuel cycle technology demonstration loop that is being built in Canada to use real deuterium-tritium mixture as a fusion fuel that will process the plasma exhaust to be pumped out and purified and to be supplied to the burning plasma again in a continuous operation mode for long term of the burning. This technology is essentially needed to any kind of the plasma and the fusion experiment in the world. So we'll be ready to provide this technology to the world fusion developers. And this business as a joint venture between the Canadians and the Kyoto Fusioneering to be supplied based on the Canadian history of the tritium processing technology and also the fusion technology based on the Kyoto Fusioneering effort. Based on both the thermal cycle and the fuel cycle technology that is we are currently building both in Japan and Canada. We would go to the next step of the fusion technology to integrate the technology into the real fusion burning experiment. And we are currently started our designing of the reactor, and we're going to hopefully construct this fusion burning experiment in about several years. And we would expect that we can demonstrate our fusion technology as an integrated manner for the near future. Thank you.